materials needed for this experiment are raisins, clear cup, and clear carbonated drink. Firstly, pour the carbonated drinks into the clear cup. Then drop 5 to 6 raisins inside the cup.
Wait for 30 seconds. Now the raisin will move up and down, which looks like it's dancing.
Hypothesis. Diffusion. The net movement of the molecules from a high concentration to a low concentration. Diffusion will occur in the carbonated drink given that the surrounding has a low concentration of carbon dioxide than the carbonated drink. Experiment observation. The raisin moves from the bottom of the cup to the surface of the top. Result. The moving raisin shows that there is a net movement of gas from the carbonated drink in the cup to the surrounding. Hence, diffusion of gas occurs in this experiment.
Why were carbonated drinks used? Carbonated drinks were used as it has something that almost no other liquid has. Carbonated drinks has a lot of carbon dioxide. The carbon dioxide inside the carbonated drink makes the drink bubbly. Thus, when the raisins are dropped inside the carbonated drink, carbon dioxide was attracted to the rough surface of the raisin, which made the raisin lighter and increased the raisin's buoyancy rather than making it heavy and dense.
When raisins were dropped inside the soda, it sinks to the bottom of the cup as the raisin has a higher density than the liquid. The carbon dioxide molecules moving around the raisin slow down. As more carbon dioxide molecules hit the raisins, more tiny bubbles made of carbon dioxide were attracted to the rough surface of the raisin. This tiny bubble made of carbon dioxide increases the volume of the raisin substantially, but contribute very little to its mass. As a result, the overall density of the raisin is lowered, causing it to be carried upward by the more dense fluid surrounding it. Archimedes' principle states that the buoyant force exerted on a fluid is equal to the weight of fluid displaced. Since the raisins now have a greater volume, they displace more water, causing the fluid to exert a greater buoyant force. The buoyant force of the surrounding fluid is what pushes the raisins to the top. Once the raisins reach the top, the bubbles pop upon exposure to the air. This makes the raisins increases its density and lose buoyancy and sink. The whole process is repeated until most of the carbon dioxide escaped. The rising and sinking of the raisin is repeated until most of the carbon dioxide is escaped. The rising and sinking of the raisins made the raisin appear to dance.
The same scientific principles are at work when a child uses a set of inflated floaties. The volume of the floaty increases the child's volume considerably. The mass of the floaty, however, is very small. The overall effect is to lower the density of the child wearing the floaties so that the child's density is lower than the pool water. Thus, the child can float. Deflating the floaty will reverse the process and cause the person to sink. Pockets of air gases or air within solid material make both natural and man-made things less dense. Airspace in boats make a boat to float on water. Life jackets are filled with spongy material with lots of airspace to make the overall jacket less dense and even hold a person. Sponge and pumice are natural material that can float because they are less dense than water due to millions of tiny airspace they contain.